Isomerism in organic compounds, structural and stereoisomerism, broad categories. Last video we have seen about structural isomerism. This video we are going to see about stereoisomerism. Stereoisomerism, the types of stereoisomerism, geometrical isomerism and optical isomerism. In geometrical isomerism, cis-trans isomerism around a carbon-carbon double bond, taking 2-butene as an example. And syn and anti-isomerism taking acetal dioxime as an example around a carbon-nitrogen double bond. Under optical isomerism, we are going to see what are optical isomers and optical isomerism, and optically active compound and what is optical activity, dextro and levorotatory compounds, and enantiomerism, enantiomers, and the condition for optical activity, condition for to be a enantiomers, optical isomerism. So, stereoisomerism. What is stereoisomerism? The branch of chemistry dealing with the study of three-dimensional nature, the spatial arrangement of molecules, are known as stereochemistry. Stereochemistry deals with the three-dimensional orientation of atoms, molecules in space. What are stereoisomers? Stereoisomers are the which have same bond connectivity but different arrangement of atoms and groups in space, known as stereoisomers. Stereoisomers have same bond connectivity but they differed in their orientation in space is called stereoisomers. So in stereoisomers we are going to see the types geometrical isomerism and optical isomerism. Here the stereoisomers possess a natural synthesis and a drug synthesis involves various stereoisomers. So stereoisomerism, geometrical isomerism and optical isomerism. The first one is geometrical isomerism. Geometrical isomers are the stereoisomers which have different atoms or groups around carbon-carbon double bonds. Here the carbon-hydrogen single bond, carbon-carbon double bond. Here the carbon-hydrogen single bond formed by the direct overlapping of p orbital, but here the carbon-carbon formed by the sidewise overlapping of the p orbital, that are pi bond. So the rotation of the carbon-carbon bond is not possible. So around groups, atoms or group attached to the carbon-carbon double bond, the same formula but their orientation in space is different, give rise to the isomerism, are called geometrical isomerism. The isomers are called geometrical isomers. The first one, cis and trans isomerism. Cis and trans isomers. Take for example 2-butene, CH3, CH, double bond CH, CH3. Second position double bond is present, so 2-butene. Here the 2-butene around carbon-carbon double bond, different groups are attached. Carbon-carbon double bond, different groups attached. Here the groups on the same side, CH3, CH3 on the same side, hydrogen, hydrogen on the same side, around carbon-carbon double bond, fixed position. So groups on the same side is called cis-2-butene. The groups on opposite side, the similar groups on same side is called cis-2-butene. Similar groups on opposite side is called trans-2-butene. So same formula but they differed in their orientation in space is called geometrical isomerism, cis-trans isomerism. Here the another one example, diamine platinum 2 chloride, groups on the same side is called cis. Similar groups on the same side is called cis. Similar groups on the opposite side is called trans. Here the cis isomer, in the case of 2-butene, cis isomer can be converted into trans isomer by increasing the heating or by absorbing the light. In that case, the isomerism around carbon-carbon double bond is disappeared, but carbon-hydrogen single bond is possible. The restoration, again on cooling the compound, we can get the mixture of cis and trans isomer. So about the geometrical isomerism, cis-trans isomerism of 2-butene. The next one is difference in the physical properties of cis and trans isomers. Here the cis isomer is more stable than that of trans isomer. Generally trans isomer is more stable than that of cis isomer because In the case of trans isomer, the groups are opposite to each other. There is a less steric hindrance. So energy is less steric hindrance, less energy, and it is more stable. But in the case of cis isomer, the groups on the similar side, more hindrance, more steric hindrance, more energy, so less stable. So generally in the cis and the trans form is more stable than the cis form. And the cis and trans form can be have different chemical properties. Thereby the cis and trans form can be separated by a chemical methods like fraction distillation and gas chromatography. In the case of propene, CH3CH double bond CH2, CH3CH double bond CH2, as it possesses the identical hydrogen atom, here the isomerism is not possible here. But in the isomerism is possible in the case of 1,3-butadiene, CH2 double bond CH, single bond CH double bond CH2. Around carbon-carbon single bond, the different groups attached the spatial orientation. So here the 1,3-butadiene written here 1,3-butadiene groups on same side cis and groups on similar groups on opposite side, it is called trans. So cis and trans isomerism is possible in the case of 1,3-butadiene. Next one is oximes and azo compounds. The cis and trans isomerism here written as syn and anti. Here the around carbon nitrogen double bond, the different spatial orientation of groups and atoms gives the syn and anti form. Here H and OH lays on the same side called syn acetaldoxime. CH3CH double bond NOH. Groups on same side is called syn acetaldoxime. The H and OH opposite to each other around carbon nitrogen double bond called anti-acetaldoxime. So we have seen the cis and trans isomerism around carbon-carbon double bond and carbon-carbon single bond and carbon-nitrogen double bond. Now we are going to see the optical isomerism. What are optical isomerism? So there are certain compounds possess same physical and chemical property, but they differ only in the rotation of plane polarized light. That isomers are called optical isomers. The phenomenon of differed in the rotation of plane polarized light, that isomerism is called optical isomerism. What is plane polarized light? When ordinary light vibrates in all directions, the ordinary light when passed through the nickel prism, the vibration is restricted to only one plane. So that is called plane polarized light. So the plane, there are certain organic compound which possess the property of rotating plane polarized light either in clockwise or anti-clockwise direction. That is called optical activity. There are certain organic compounds which rotates the plane polarized light either to the clockwise or to the anti-clockwise clockwise or anti-clockwise direction. That property is called optical activity. The isomers are the compounds which rotates the plane polarized light that are called optical isomers. So the substance which rotates the plane polarized light to the clockwise direction is called dextrorotatory or plus sign. The compounds which rotates the plane polarized light anti-clockwise direction is given by levorotatory L or minus sign. So the compounds which possess the same molecular formula, same physical and chemical property, differed only in the rotation of plane polarized light. So this isomers, the isomers which possess same physical and chemical property differ in terms of the direction of rotation of plane polarized light. And they rotate the equal angle but in opposite direction. This type of isomers are called enantiomers. For example, CH3CHOH COOH, CH3CHOH COOH, D lactic acid and L lactic acid, plus lactic acid minus lactic acid. Lactic acid rotates the plane polarized light to the clockwise direction is called D lactic acid. Lactic acid which rotates the plane polarized light to the anti-clockwise direction is called L lactic acid or minus sign. So the lactic acid only differed in the direction of the rotation. The extent of rotation is same, the angle of rotation is same, but they differ in the direction of the rotation. So this type of isomerism is called enantiomers, and these isomers are called enantiomers, D lactic acid, L lactic acid. This phenomenon is called enantiomerism. This phenomenon is called enantiomerism. So the enantiomerism. Next one is, what are the condition for the enantiomerism or optical isomerism? What are the condition is, 4 different groups should be attached to the center carbon atom. They are not supposed to possess any symmetry, center of symmetry, point of symmetry, the identical symmetry. So absence of symmetry, that is carbon atom is achiral in nature, and they possess non-superimposable mirror image. So if you impose the one mirror image over the other, the OH coincide with the H and H coincide with the OH. So they possess non-superimposable mirror image. These are all the conditions for the optical activity of the compound. So the 4 different group attached to the central carbon atom, achiral carbon atom, absence of symmetry, non-superimposable mirror image are the condition for the optical activity. So optical isomerism, optical isomers, what is optical activity, optically active compounds, what are dextro and levorotatory substance, what are enantiomerism, what are enantiomers, and condition for enantiomer optical activity. So these are all the points we have seen. Subscribe for more videos. Thank you. Share with your friends. Thank you.